So what you got to remember is that this is actually horizontal ground. Okay, so this is actually like a horizontal ground, and see E to A. Does everybody see E to A? Everybody see that line E to A? That line and any one of the three. See this line here? I just made there. That's a right angle triangle. See this line I'm moving to here? That's a right angle triangle as well, because it's a pole sticking up from horizontal ground. So if I do EAB, and any of that would have seen my videos done in the 3D, I always write them down. I always do it like this. EAB. Okay? Yes, it is. Now, we're given the angle. What angle are we given? We're told A to E is 15. What we're told about C to D? C to D is 12. Okay? So, I'll make this one over here. And C to D is 12. You're still 90 degrees. Do I know any other thing about them? I know ABE, A to B to E. So now that's 30 degrees. So straight away, this triangle on the left seems to be the one I have the most information on, isn't it? You have two choices. You can either use the sine rule or SOHCAHTOA. So for those of us that did SOHCAHTOA, we're looking for X, aren't we? AB. So I'm going to do tan. Opposite over adjacent is tan. So I can do tan 30 equals 15 over X. For those of you that use the sine rule, here's what you guys be looking at. I think you guys be looking at that. How do I know this angle is 60? Can anybody tell me? How do I know that angle is 60? Huh? Yeah, isn't it? So if you use the sine rule, it had to be 15 over sine X, and then the other one would have been 15 over sine 30. I'm wrong about that. And 15 over sine 30 and X over sine 60. All right. Now, whichever way you decide to do it, doesn't matter. Bring up the X, bring down the tan 30. 15 over tan 30 and equals 15 root 3. Now, by the way, it told me to take off a mark if you don't put down the word meter. I didn't. But I'm just telling you for the leaving certs, if you don't write down meters, that's a 9 out of 10. Can you all remember that now? Meters, meters squared, whatever it is, keep putting in the units every time. You get the same answer when you do it this way. You get 15 sine 60 all over sine 30, and you get the same answer. Okay. Next question. Find B to C. Well, B to C is located in this triangle to the left, DCB. Everybody see DCB? Okay. Wait 1 second. Okay, there it is there. Any measurements I'm missing on DCB? Is there any measurements I'm missing? What? Oh, it says CBD is 45, does it? Right, give me a sec. All right. So here's what we're going to do. We're going to put 45 here. Ever see it? And we're looking for B to C, aren't we? We're looking for B to C. Well, most of you figured this out quite quickly. If it's a 45-degree triangle, the opposite and the adjacent are actually the same. So X has to equal 12. Most of us would have written down tan 45 equals 12 over X. And that's what most of us would have done. Okay, so we bring this down and cross multiply up the X and bring the tan 45 down, but tan 45 is 1, so just cross multiply up the X. X equals 12. Full marks? No. 12 meters. Now I have full marks. All right. Next thing. Use the sine rule to show that AC is 29.13. correct to 2 decimal places. So it says the sine rule, lads. The sine rule. That does not mean the cosine rule, and it does not mean Pythagoras' theorem. Okay. Now we're going to grab our diagram here. Just this little part here. Oh dear. I don't want that. Okay. Okay. Now, I'm just going to grab this triangle. Is the triangle ABC right angled? Yay or nay? It doesn't tell you, does it? So, because it doesn't tell you it's right angled, you cannot assume it's right angled. Therefore, SOHCAHTOA and Pythagoras' theorem are gone. You cannot use them. And it also says use the sine rule, which would be your first hint. Now, what's A to B again? 15 root 3. What's B to C? 12. Does it give me any angle I could use? It gives me CA. It gives me CAB is 24.3. A quick note for everybody in the class. You are not allowed to use 29.13. Do you get it? You're meant to prove it's 29.13. So if you use 29.13 and gathered all the information backwards, I still can't give you anything. I can give you an attempt 4 out of 10 at most. Okay? So you're not allowed to use 29.13. You need to prove it's 29.13. So here's what we're going to do. We're going to do the sine rule, lads. So what's the first thing we can do? Let's do 12 divided by sine 24.3 equals, call this angle x. Is that okay with you guys? 15 root 3 all over sine x. Here's what we're going to do now. Bring the sine x up. So it's 12 sine x equals 15 root 3 sine 24.3. Then see that 12? We're going to bring it under. And then we're going to get this answer and sine inverse it. So it's 15 root 3. Sorry, I pressed the fraction button. 15 root 3 sine 24.3 all over 12. Get that answer, which is 0.8909. Be careful when you're rounding, can I say? You have to be really careful when you're rounding. Okay? Try and keep as many of them as you can here. So 0.891 maybe. 0.891 if you're doing 3 decimal places. Sine is really weird. It gets very temperamental the closer it gets to 0.9. So some of you did a mild round off and your result ended up quite a bit away. So if it's not too much hassle, try and use 3 or 4 decimal places where possible. Okay? And then sine x. That's sine inverse the answer. You could also store it in your calculator, but shift sine inverse 0.891 and 62.99, otherwise known as 63, I suppose. 63 degrees. Anybody get 63 degrees? Okay. Now, that's not the question, though. Now, there is an option here. Shh. Guys, cosine rule is on, isn't it? I could use the cosine rule, but what's stopping me from using the cosine rule? The fact that it keeps this question specifically says use the sine rule. My argument is I already used the sine rule, and now I'm using the cosine rule. It's a bit of a silly question. Wouldn't happen in the leaving cert. It would happen in the mock, but won't happen in the leaving cert. They'd leave it open-ended, I'd say. So, just for argument's sake, to cover my bases, because it says use the sine rule, I'm going to use the sine rule again. So we call this m. Okay, m over sine. Oh, wait. I'm wrong. That's 63, isn't it? Which makes this one what? 180 take away. 63 take away. 24.3. What do we get? 92.7. Okay. Over sine 92.7 equals 12 over sine 24.3. Okay, 13 sine 92.7 all over sine 24.3. And what do we get? Anybody? Did you get 29.13, was it? What? Oh, it is 12. Sorry, guys, it's 12. Thanks for that. Now, guys, this is a proof question. If you get this question wrong, what can happen? You can still use the answer of 29.13. 29.13, right? Rounded. Full marks? No. Okay. Wants me to do E to D. Now, E to D is sorry. E to D is this one here. Okay. So everybody see E to D? Okay. Now, sheet new page. Oh, what happened there? Let's go again. Okay. So there's there. And we're going to use all our answers from previous to try and get this out. Okay. So when we're looking at E to D, what I'm thinking is E to D. We want this here, don't we? Oh, this is a cheeky question. I remember it now. Look at this. See this what I'm constructing here? I'm constructing myself a right angled triangle. And for argument's sake, I'll call this N. See the triangle END. END is a right angled triangle. END. Does anybody know the length of E to N? If that's 12 and that's 15, that's 3. Now, do you know what we have to get? If we know the length of A to C, I think we just got that, didn't we? What's the length of A to C? What? And even if we didn't get it right, the question still told us what it was. And now we're just doing Pythagoras' theorem. And to be fair, lads, that was a tough question. Okay, add it together. Square out your answer. We got 29.28 or 29. 2A. Okay, meters. Finally, find the angle EBD. Here we go. So lads, if I move this down, it wants the triangle EBD. Which triangle's EBD, lads? This angle there. Now, here we go. First things first. We know that that's 29.2A. Do we know the length E to B? What is it? I don't think we do. Do we know the length A to B? What's the length A to B? What? 15 root 3. Okay. That's small a is going to be determined using Pythagoras' theorem. 15 root 3 squared plus 15 squared. Okay. Throw it all into the calculator. Square your answer. So it's 15 root 3 squared plus 15 squared, yeah? And we get 900. Is that okay with you guys? Square root 900 and we get 30. We're going to repeat the same procedure for what one? We're going to, C to D is 12. Do we know what BC is? I think we do. What is it? Oh, 12 as well. Pythagoras' theorem for M. M squared equals 12 squared plus 12 squared. 12 squared plus 12 squared is actually 288. I'm going to square root 288. And we get an answer of 12 root 2. Now and only now am I ready to take on this triangle here. Okay, so if I was to tip X out my stuff now here, so go white and go here. Look at this. What am I left with now? Just left with the triangle I want now, haven't I? Everybody see that? What rule should I use? Cosine. 3 lengths, no angle. Shh. Cosine rule. What's it? C squared. Oh, sorry. A squared equals B squared plus C squared minus C cos A. Okay, cool. And then A equals what then? What's it? 29.2A squared equals 30 squared plus 12 root 2 squared minus 2 times 30 times 12 root 2 cos A. All right, I'm going to be a bit lazy here. It's going to be the red one, take away the green one, take away the blue one, isn't it? When I bring them over, I'm going to take them away, yeah? So I'm just going to go all in one go on this, just because I'm time conscious. So here's what I'm going to do. And what will happen is I'll get minus 330.6816. And that will equal all this here. It's 60 times 12, which is minus 720 root 2 cos A. Do you notice that both sides are negative? So what can I do then? Both sides are now positive, yeah? And bring the 720 root 2 underneath. Cos inverse that, and you get your answer. How many people got 71 degrees? And lads, that was an exceptionally hard question, I have to say. Oh, sorry, 74, was it? So how much you get? 71.